Okay, so we looked at the basic sine and cosine and tangent curves and what they look like and those critical points. So now we're going to apply some transformations. So transformations we can apply to these curves are, first of all, dilatation, which is what we're going to do today. So a dilatation, if you think of your eye dilating, it means it gets bigger and smaller. So it's a stretch or a compression. Okay, so it doesn't move it. It either stretches it and makes it bigger or compresses it and makes it smaller. So a vertical, the other two transformations we can do are shifts. So those are translations. And the third one would be a reflection. So today we're going to look at dilatations. The vertical dilatation is represented by the letter A. So you'll see your function here. So if there is a number multiplied at the beginning of the function, then that is going to stretch it or compress it depending on whether it's a number bigger than 1 or a fraction or a decimal. Okay, this is also the amplitude of the function. So in trig, we call the A the amplitude. So the amplitude is the vertical stretch. Okay, so let's say we wanted to graph the function y equals sine 2x. We're going to be using mapping notation for the most part. So mapping notation describes what's happening to each of the x and y coordinates. Okay, so mapping notation looks like this. You probably have seen it, but maybe not. So let me move this up. So it is an easy way to determine what is happening, especially when there's lots of things going on. If there's only one thing, then you can apply the transformation directly to the graph. But if you have a couple of transformations going on, then mapping notation is very useful. So mapping notation looks like this. If you have a coordinate on the graph xy, and then you draw an arrow, and then you are going to describe how the x and y coordinates are changing. So if I'm graphing y equals 2 sine x, this 2 is representing a vertical stretch because it is being multiplied by sine x, and it's going to affect the y coordinate because it's outside the function. So I'll talk about outside and inside the function. So outside the function means that we're going to calculate sine x first and then multiply the answers by 2. So the x is not going to change, the y is, because it's done after the function. Okay? If I talk about inside the function, we're going to change x first and then apply the sign. And that means that it would be inside brackets. So this is outside the function. It's multiplied, which means it's a stretch. So what that means is that x is not going to change, but y is going to be multiplied by 2. So that is describing what's happening to the x and y. And then we will write down those 5 critical points that we talked about in the last lesson on sine. So let me move this down a bit. So if you look at the graph, this is just regular sine. These are the 5 points that we always use. Right? Where it starts at 0, 0, where its maximum is. Its maximum occurs at 90 and 1. Then it goes back to 0, and then the minimum occurs at 270, negative 1, and then it goes back to 0 at 360. So these are the 5 critical points that we always start with. And then we're going to apply this transformations to these points. So we said in mapping notation that the x is going to stay the same, and the y is going to be multiplied by 2. So x stays the same, and then 2 times 0 is 0. X stays the same. 2 times 1 is 2. 2 times 0 is 0. 2 times negative 1 is negative 2, and 2 times 0 is 0. So these are my new points that I'm going to put onto the graph. So that stays the same. 1 becomes 2, stays the same. Negative 1 becomes negative 2. And then this is my new graph. So I've vertically stretched it. So this is 2 sine x. And then it would happen on this. This one would be double. This one would be double. And there's my graph. So that is a vertical stretch of 2. The x stayed the same. Okay? We could graph the function 1/2 cosine x. So my mapping notation would be that, again, x is going to stay the same. Now the half is getting multiplied by the y. So it would be 1/2 y. This time we're using cosine. So cosine has different points that we're going to start with. These are the 5 points on cosine. So cosine starts at the top of the cycle, goes to the middle, down to the bottom, back to the middle, and then back to the top. And then we're going to apply this mapping notation to these points. So x is going to stay the same. Oh, that was weird. And then y will be multiplied by a half. So a half of 1, a half of 0, a half of negative 1, a half of 0, and a half of 1. Okay, so we're multiplying all the y values by 1/2. And then on the graph, it would look like this. So 1 becomes a half. So like I said, if it's only one transformation, you could probably just do it right on the graph because it's pretty obvious. But once we start doing, 3 or 4 transformations, then mapping notation becomes very useful. So here I have a vertical compression of a half. So the graph is being compressed by a half vertically. Okay. We can also compress or stretch it horizontally. So that, you'll notice the difference is that now the number is inside the brackets, right? It's in between sine and x. That means that I'm changing x first and then applying the sine. So that's going to change the x coordinate. Okay, so when we talk about transformations, we talk about inside and outside. Inside will change the x coordinates, outside will change the y coordinates. The other thing to keep in mind is that when it is a horizontal dilatation, it affects the x coordinate in the inverse way. So instead of multiplying by 2, it'll be multiplied by a half. So it's always the inverse. And it changes the period of the function. So a normal period is 360. So let me write this out here. So normally the period is 360, but the C value is going to compress or stretch that 360. Okay, so this C value is 2. So the period will be the normal period divided by 2. So now the new period of the graph is going to be 180. That means we're going to complete one cycle in 180 degrees instead of 360. And the 2 actually means we're going to get the graph in twice in 360 degrees. Okay, each one being a half. So my mapping notation, this time x is going to be affected and y is not. Okay, so x is going to be the opposite or the inverse of 2. It'll be a half. And so it's sine. So remember, these are my 5 points on sine that I'm going to start with. So on the questions that you're going to be doing, they're going to ask you to write out the mapping notation. So it's a good habit to get into. And so now the x's are going to be affected, and they're going to be a half. So I'm taking all these x's and dividing them by 2, and the y is not going to change. The y will stay the same. And those are my new points. And so each of these is 90, so I'm just going to divide it up into 45 degrees. So make sure that your axes have numbers on them, because it has to be clear what you're graphing. So we're starting 0, 0 is not going to change, but 91 is going to change to 45, 1. Okay, and then we're going to graph 90, 0, and then 135, negative 1, and then 180, 0. So my new graph looks like this. And so I got that graph completed in 180 degrees. If I repeated it, I can see that I would get the graph in twice in 360. Okay, and then I could do the same on this side. So it would be here, 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 and here. So the graph has been horizontally compressed by a half. So in the normal 360, we're getting it in twice, the period being 180. Okay, this one is cosine 1/2 x. So we will always be asked what the period is. The period is normally 360, and you divide it by any c value. In this case, c is a half. So we're dividing 360 by a half. So remember, dividing by a half is the same as multiplying by 2. So the period of this graph is going to be 720, which means in 360, we're only going to get in half the graph. That's what that means. And so it's cosine. So let's write out our mapping notation. So our mapping notation, the x is going to be double, and the y is going to stay the same. Okay, so we'll write out our 5 points on cosine. These are our 5 points on cosine. And then we're going to apply this to those points. So we're going to double the x, and y stays the same. So because I have the graph already, I've got the grid already set, I'm only going to see half the graph, right? If I were graphing this, I probably would change the x-axis to go up to 3 or up to 720 so that I could get in a complete cycle. So generally we like to get in 2 complete cycles. I'm not going to be able to fit it on here, but normally that's what we do. So we're still going to start at 0, 1, but at 180 we're going to go to 0, and at 360 to negative 1. So we're only get in half the curve, and then that would repeat over here. So it'd be here and then here. So there's one complete cycle. So that graph has been horizontally stretched by 2. So it's twice as wide, and we'd have to go to 720 on each side to get to complete the graph. Okay, so these are a few practice questions from the guide. They're on page A18 and A14. And so you're just applying the transformations to the graph. So in A, we have a horizontal stretch. It doesn't really matter what the function is. This one happens to be sine, but f is just representing the function. So we want to double the x and leave the y the same. Okay, so we could just pick these points on sine, and we can apply those transformations to those points. So I'm going to double the x, leave the y the same. 180, 0. So on the graph, the first one, the 0, 0 would stay the same, but you'll notice that 91 is going to now move over to 181. And then 180, 0 is now moving over to 360, 0 because I'm stretching it. And then that would be the same here. This point is going to move over to here. And that would be horizontally stretched double. So I'm only going to get in half the graph. This one, again, the x is being affected in the opposite way. So 2 will become a half. It will change the x. The y will not change. So you'll notice the difference is that these numbers are inside the brackets. So they are being applied to the function first, which changes x. And so I will pick some points on my graph and apply this transformation to those points. So a half of 0 is 0. The next point is 90, 0. So a half of 90 is 45. And then I'll pick another point. 180 is at -1. So a half of 180 is 90. And the y stays the same. So this point stays where it is, 0, 0. But this point is now half. This point is now at 90, and so on. So this point comes over. So here's my graph. All right, so I'm horizontally compressing it by a half. So just pick some points, apply the transformation to those points, and compress it. This question is asking you just for the period, okay? So the period is always determined by taking the normal period and dividing it by any value of c. So c is the number between sine and theta. So here the period would be 360 divided by 4, so 90. Here the period would be 360 divided by 3/4. So dividing by 3/4 is the same as multiplying by 4/3. Okay, so what's that? 120 times 4 is 480. So that would be the period. Okay, you can do C on your own. Here the period would be 360 divided by C, which is 3/5. So multiply by 5/3. Okay, so whatever that is, that's 120 times 5. So the period is 600. Okay, here it's just 360 because there's no transformation. All right, so that's just calculating the period. Here it wants you to sketch the graph on the grid. So you can do mapping notation. So there is a horizontal compression of 1/4. Remember, C is 4, so it's the inverse of 4, which is 1/4, and y stays the same. It wants you to graph cosine, so we'll write out the points on cosine. So these are points that you always use. And then we'll apply this transformation to these points. X, we're going to divide the x by 4. So that will remain the same. 90 divided by 4 is what? 27.5 divided by 4, 22.5. And that stays the same. 180 divided by 4 is 45. 270 divided by 4 is 67.5. And 360 divided by 4 is 90. So on my scale, make sure that you put numbers on the scale. So I'm gonna complete one cycle in 90 degrees. So I can put whatever I want on the scale. I'm going up to 1 and down to -1. So I'll put that in here. And then I can divide up this as I want. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 16 squares. So maybe I'll divide that in half. So there's 90 degrees. So I want to draw the cycle in twice. So since the period is 90, I'm going to go to 180 and get it in twice. And then I'll divide that 90 in half and then in. So I want to have 4 equal increments on my scale. So each of these increments is going to be 22.5. So make sure that you put some values on your x-axis so that it's clear what you are graphing. And that's the other benefit of mapping notation, is that when I look at that mapping notation, I see what you're trying to graph. So even if your graph is incorrect, I can still see that you were trying to graph those values, and it's easier for me to give you some marks for that. So 0, 1, this is 22.5 here, so that's 0, 45 is -1, back to 0, and then 90 is 1. So there's one cycle, and then I would just repeat it. Okay, so there's my graph. I have one complete period in 90, and I've drawn it twice. Okay, so you would do the same for 3 pi over 2. You're doing cosine again, so the mapping notation. So we're going to do the inverse of 3 over 2 would be 2 over 3. So you're going to multiply each of the x values by 2 over 3. So 2/3 times 0 is still 0. So we're going to do 90 times 2 is 180, divided by 3 is 60. And then the next point, so 180 times 2 is 360, divided by 3 is 120. And then the next point, 270 times 2 is 540, and then 540 divided by 3 is 180. And I can also see that my x values are going up by 60. And then 360 times 2 is 720, divided by 3 is 240. So those are my new points. So on my grid here, I'm still going up to 1, down to -1. I have to complete a cycle in 240. So each of these are going to be 60. So I might say 60, 120, 180. I'll just write them up. So 60, 180, or 120. So this is 180. Oops. Let's erase that. Making a mess here. And then this would be 360. So make sure that you put a few numbers on your scales so that it's clear what these are graphing. So that's 0, 1, 60 is right here, 120 is here, 180 is here, and then 240. So there's one cycle. Once you get in one cycle, you just repeat, right? Because once you have one cycle, you know the pattern. And there's my graph. Okay. And then this is similar, but just with sine. So I'll just write out the mapping notation, and then you can finish the graph. So sine, this time we're just graphing sine. X is going to be the opposite of a quarter, so it'll be 4. And y will stay the same. And then this one, x is the opposite of 2, so a half, and y will stay the same. So you're just going to write out your critical points, apply that to each of these x values, and then the y stays the same.